Comets are some of the most spectacular yet mysterious visitors to our inner solar system. They're like cosmic snowballs left over from the birth of our solar system, hurtling through space. But what's really fascinating is that they aren't all just boring grey rocks. Some of them put on a real light show, shining in vibrant colours. Today, we're diving deep into one such celestial wanderer, Comet 3 IATLAS, and exploring the incredible science behind why it might appear green, blue, or even a milky white. First, let's talk about the stunning emerald green glow. This isn't just a random color. It's a specific chemical signature. As a comet like ATLAS gets closer to the Sun, the ice on its surface doesn't just melt, it sublimates, turning directly from a solid into a gas. This process releases dust and gas, forming a huge glowing cloud around the comet's nucleus, called a coma. Now, deep within this coma, a fascinating chemical reaction happens. The intense ultraviolet light from the sun breaks apart simple molecules that were frozen in the comet's ice. One of these is diatomic carbon, or C2. When these C2 molecules are zapped by sunlight, they absorb the energy and then re-emit it as light. And guess what color they glow? A brilliant, ethereal green. So, when you see a photo of a green comet, you're witnessing this beautiful process of fluorescence, a cosmic light show powered by the sun itself. It's a direct sign that the comet is active and shedding its ancient materials into space. But the green isn't the only color in the comet's palette. Sometimes we see a striking blue hue, and this color tells a different story. The blue color is typically found in the comet's tail, specifically the ion tail. Comets actually have two main tails. There's the dust tail, which is often curved and appears whitish or yellowish because it eschews sunlight, reflecting off tiny dust particles. Then there's the ion tail, which is straighter and points directly away from the sun, pushed by the solar wind. This tail is made of gas particles that have been ionized by the sun's ultraviolet radiation, meaning they've lost electrons and now have an electric charge. One of the most common molecules to get ionized is carbon monoxide. When these carbon monoxide ions are excited, they fluoresce, emitting a distinct blue light. So, while the green coma envelops the comet's head, this long, thin blue tail streams behind it, like a celestial banner. Seeing both the green and the blue is like getting a 2-for-1 deal on cosmic chemistry. Now, what about that milky white appearance? This is perhaps the most common look for a comet, and it's the simplest to explain. Think about it. What are comets made of? Ice and dust. The milky white color we see is simply sunlight reflecting off the vast cloud of dust, particles that are released along with the gas. This is the same principle that makes clouds in our own sky look white. The countless tiny dust grains in the comet's coma and its dust tail scatter sunlight in all directions. Our eyes perceive this scattered light as a soft, hazy white or yellowish-white glow. The brightness and prominence of this white color depend entirely on how dusty the comet is. A very dusty comet will have a brilliant, bright white coma and a broad, curved dust tail that can stretch for millions of miles across the sky. So, when Comet Atlas looked more white than green, it was likely because it was releasing a massive amount of dust, overpowering the more subtle colors from the fluorescing gases. So, we have green from diatomic carbon, blue from carbon monoxide ions, and white from reflected sunlight on dust. But can a comet show all these colors at once? Absolutely. The appearance of a comet is a dynamic and ever-changing spectacle. As its orbit takes it closer to or farther from the Sun, its activity level changes. A comet might start off looking mostly white and dusty. As it heats up, the green coma can become more and more prominent. During a particularly strong burst of activity or when it's perfectly positioned relative to the Sun and Earth, the blue ion tail might become incredibly distinct. The view we get from Earth also depends on our viewing angle. Sometimes the dust tail and the ion tail can overlap from our perspective, blending the colors together. It's a complex interplay of chemistry, physics, and orbital mechanics. Let's think back to Comet Atlas. When it was first discovered, astronomers were incredibly excited. It was brightening rapidly, and many hoped it would become a great comet, easily visible to the naked eye. We saw those gorgeous green hues in early observations, a clear sign it was highly active. But then, something unexpected happened. Instead of getting brighter, it started to fade. Telescopic observations revealed that the comet's nucleus had fragmented, it was breaking apart. This fragmentation event likely caused a huge sudden release of dust, which could explain why some views of the comet shifted to a more diffuse milky white appearance. The comet's structure was literally disintegrating, creating a massive cloud of reflective debris that temporarily overwhelmed the green glow of the gas. It was a dramatic and somewhat sad end to what could have been a spectacular show, but it gave us a front-row seat to the violent and unpredictable life cycle of a comet. Studying these colors is not just for pretty pictures. For astronomers, these colors are like a cosmic fingerprint. By analyzing the light from a comet with an instrument called a spectroscope, they can break it down into its constituent wavelengths. Just like a prism creates a rainbow, this spectrum reveals exactly which chemicals are present in the comet's coma and tail. This tells us about the composition of the early solar system, because these comets have been in a deep freeze for billions of years, perfectly preserving the primordial materials from which the planets, including Earth, were formed. Some scientists even believe that comets delivered water and the basic organic molecules necessary for life to our young planet. So, by studying the green of diatomic carbon or the blue of carbon monoxide in a comet like ATLA's, we are essentially looking back in time, piecing together the story of our own origins. So, the next time you see an image of a comet, don't just see a fuzzy blob. Look closer at the colors. If you see green, think of the powerful ultraviolet sunlight breaking apart molecules in the comet's atmosphere. If you see blue, picture the solar wind carrying ionized gas millions of miles into space. And if you see a soft, milky white, imagine a vast cloud of ancient dust, freed after billions of years, reflecting the light of our star. Comets, like 3IATLAS, are not just passive travelers. They are active, dynamic worlds that paint the night sky with the story of our solar system's creation. Each color is a chapter in that incredible story. Thank you so much for joining me on this cosmic journey today. It's truly amazing what we can learn just by looking at the light from these distant visitors. If you enjoyed this deep dive into the colors of comets, please hit that like button and consider subscribing to the channel for more space adventures. Let me know in the comments if you've ever seen a comet yourself. Until next time, keep looking up.